My name is Michail Savvas, and I am a theoretical mathematician working on the study of shapes and how different objects can fit within those shapes. In terms of how we go about studying shapes and objects within them in research, one common theme is that it is often better to study all of the objects we're interested in at once rather than only one of them at a time. The advantage of this approach is that it gives rise to new spaces which parameterize the objects we're interested in and whose structure can greatly enhance our understanding of them. As an example, we can think of a geographical map, let's say a map of the United States. If we point our finger to one spot of that map, it will probably correspond to maybe a city, a village, a road, and in any case, it will represent an object of interest in itself. In that sense, the map is a parameter space of objects, which could be cities, for example. On its own, it represents the Earth, which is a space as well. It is not very easy to find concrete examples that everyone can immediately relate to and can communicate the nature and the interest of the problems that we are studying. Here is an example. We can think about this little coffee table that's made out of paper. If you look carefully at every little cube that's made out of paper and forming this table, is actually made out of instructions to assemble a dresser, a piece of furniture. In that sense, this shape, this table, is a parameter space parameterizing dressers, which in this example are the objects we're interested in studying. The objects I study in my day-to-day research are called Calabi-Yau manifolds. I'm specifically interested in studying curves and other objects that live within them. Besides their mathematical complexity and interesting structure, a main motivation to study these shapes is theoretical physics, and in particular string theory. String theory is a proposal for the theory of everything around us. It predicts 6 extra dimensions beyond space and time. And in particular, that these dimensions, they're curved, they look like a Calabi-Yau manifold. What I like most about the work I do is, first of all, that it is very intellectually challenging. The questions we're studying are very interesting and deep in their nature, and what is more, there's so much more that we don't know compared to what we actually know. So these questions, there's an endless supply of them, which is great.